Hi, and welcome to Always Eclectic Stacy. This is Always Eclectic Chemistry, and you're in our ionic bonding series. Today we're going to talk about the formation of ionic bonds, cations, anions, metals, nonmetals. Now, let's go catch out what's positive. Catch you later. Hi, and welcome to Always Eclectic Stacy. This is Always Eclectic Chemistry, and today we're talking about ionic bonds. And our first big question is, how are ionic bonds formed? Well, ionic bonds occur when metals and nonmetals attract each other, share an electron, and form a bond. This is an electronegativity beyond a covalent bond, and the electronegativity is so great that the one seals the electron, causing the opposite attract situation. This occurs between a metal and a non-metal. So if you remember the periodic table, and we're going to go look at notes in a second, columns 1 through 13 are all metals. They all form a positive cation, and they will give their electrons in the valence shell to their counterparts, the negative anions. And that's columns primarily 15, 16, and 17. Now, when we talk about column 14, normally it's the kumbaya column. They like to share, but there are several elements in column 14 that do act like transition metals. And we'll talk about what that looks like in a second. Okay, let's talk about how columns, the Lewis dot, the charge, and then what that would look like, the Lewis dot, once we figure out the charge. So column 1, remember these are your alkali metals. The Lewis dot would be like lithium with a single dot to the right. Charge of all column 1 elements is 1 plus because they lose their singular Lewis dot. And a Lewis dot with charge is Li 1 plus. Now, if you go to column 2, oops, I don't want another blue. This is again your alkaline earth metals. This would be like Mg or magnesium. You do a dot to the right, to the left. The charge is 2 plus. And a Lewis dot with charge would be like Mg 2 plus. Again, you're showing that it's given up 2 valence electrons. Now, columns 3 through 12. These are your transition metals. And you have to be given the charge. Because they have multiple oxidation states, which means they can have multiple charges. So for columns 3 through 12, these are your transition metals. You either have to be given the charge or a way to find the charge because they have multiple oxidation states. For column 13, this is like boron or aluminum. It has 3 valence electrons, so it has 3 dots on the Lewis dot. Because there's 3 there, it's a charge of 3 plus. And when they make the Lewis dot with charge, again, you're losing all 3 dots and you're getting a 3 plus charge because you're giving away 3 valence electrons. Electrons are negatively charged, so when you give them away, you become positive. Now for column 14, this is more similar to transition metals. The ones we talk about in column 14, they act like transition metals. So you have to be given a way to find their charge. And this is going to be more like your tin and lead. Then we're on to column 15, which has 5 valence electrons. So this would be like nitrogen. So 1, 2, 3, 4, 5. It has a 3 minus charge. So it's going to have that 1, 2, 3, 4, 5 in the Lewis dot. And the big difference now is that you're gaining 3 electrons. 1, 2, 3 to fill in that octet. And when you're doing that, please don't forget to show your 3 minus charge. For column 16, that's like oxygen. It has 6 valence electrons, so it's going to have 6 Lewis dots. Got a 2 minus charge, and so that means in this Lewis dot that has those 2 ready to bond, it's actually gaining an electron in each of those to fill its octet, and that's why it has a 2 minus charge. It's gaining 2 electrons. And then finally, for column 17, like your fluorine, it has almost a full octet anyhow with 7 valence electrons. It's got a 1 minus charge, meaning it's going to take 1 more valence electron to fill its octet. And so it's going to be, you're going to show that in the Lewis dot by adding 1 valence electron and then adding a 1 minus charge. And as always, I know we're talking about column 18 as being the noble gases and that they have full octets already. So although we do know that they have 8 valence electrons, when we're talking about ions, we really don't talk about them because they really don't bond outside of exceptions. So we have columns 1 with 1 valence electron with a 1 plus charge, column 2 with 2 valence electrons with a 2 plus charge, columns 3 through 12 and column 14 that are transition metals or they act like transition metals. So you either have to be given the charge or a way to find the charge because they have multiple oxidation states. Then you have column 13, which has 3 valence electrons and a 3 plus charge, column 15, which has 5 valence electrons and a 3 minus charge, column 16 that has 6 valence electrons and a 2 minus charge, column 17 with 7 valence electrons and a 1 minus charge. Because remember, the big trick with ions is that it's a cation, and cations are metals joining with an anion. And these are generally nonmetals. And I say generally because every time I say always, an exception crops up. So it's a cation, which is a metal, and an anion, which is a nonmetal. And a nice way to remember that cation is positive because your metals are positive is that cats are positive. Because if you remember, cats have pause, cats then become positive, and that helps you remember the difference between cations and anions. Thank you so much for watching Always Eclectic Stacy. If you like this content, please do not forget to like and subscribe. Have a fantastic day.